Writing and solving proportions is one of my all-time favorite ideas in 7th grade math, and mainly because it's something that I use all the time in my everyday life in problem solving. So the first thing that we're going to write down is a definition here of what a proportion is. So on your note page, a proportion is an equation showing two equal ratios. And right next to that, I'd like you to go ahead and show this as well. Here's what it looks like. It looks like a fraction that's equal to another fraction. Okay, because we learned in our ratios lesson that we could write ratios three different ways, and one of those three ways we could write a ratio was as a fraction. So a lot of times you'll see me talking about a proportion is a fraction equal to a fraction. The nice thing about proportions is that we can solve them in three different methods. So the first method that we're going to talk about is called unit rate, which should sound a little bit familiar. Another way that we're going to solve these is with equal fractions or equivalent fractions. And the third way, which you may remember from 6th grade, everybody's favorite, cross products or cross multiplication. So the first thing that we're going to solve here is a proportion that can be solved using a unit rate. So we have on a 5 on the bottom and a unit rate, if you remember from your notes, will have a denominator of 1. So I asked myself, how did I go from 5 to 1? Well, I must have divided by 5. And what I do on the bottom, I must also do on the top. 40 divided by 5 is 8. So my proportion would look like this. 40 over 5, this is a ratio, is equal to 8 over 1. This is another ratio. Two ratios equal to each other is called a proportion, or you'll hear me say a fraction equal to another fraction. Here's an example of solving by using equivalent fractions. In this problem, I can see a relationship between my numerators. I can see a relationship between 4 and 12. I know that 4 times 3 will give me 12, or I can do the inverse of that, which is 12 divided by 3 gives me 4. And what I did on the top, I need to do on the bottom here. So 24 divided by 3 is 8. So here's what my final proportion would look like. 4 over 8, it's equal to 12 over 24. Now while you're writing that down, I'm going to erase this, and I'd like to challenge you tonight to solve this proportion at least one other way. So while you're working on this, I want you to come up with one other way, at least one. I bet you could come up with more, other than the way that I just did to solve this. There's going to be lots of different ways to solve this proportion. And here's the cross product method. And I want you to make a note, special note, that cross product is the one that always works. What it looks like in your notes for you to write this down algebraically is A over B equals C over D. And when we use cross product, it looks like this. We do the top left times the bottom right first. And so if I multiplied A times D, that would give me A D. And that's going to be equal to or equivalent to what I will do second, which is this times this, C times B, or B times C. Remember that multiplication is commutative, so it wouldn't matter if I reversed the letters. I could also write dA equals CB. Those are the same. But what you'll see in your textbook definition, the algebraic way to show cross product is like this. So what I'm going to do over here is what I've just done here. I always start in the top left corner. 4 times x in algebra is written 4x. That is the correct way to write that. Remember, we're pretty lazy in algebra, so I don't need to spend the extra time to put the little dot there or the little x multiplication symbol. It's just 4x. And 5 times 7 is 35. And then to finish solving this, I need to get this x by itself. And the way that I will do that is to divide both sides by 4. The reason I divide both sides by 4, because what is 4 divided by 4? It's 1. So now I have 1x, which in algebra is the same thing as just x. And remember that whole lazy conversation we just had? We don't ever write 1x or 1l or 1m. We just write the variable by itself. We don't write that 1. And then I can figure out here 35 divided by 4. 4 goes into 35. 4 goes into 35 8 times. 4 times 8 is 32, which means since I was trying to get to 35, I would have 3 left over out of 4. The other way to come up with an answer that would be perfectly acceptable, the decimal answer here would be to do the long division. 35 divided by 4. I see that I'm going to have 3 left over, and I need to add this. 4 goes into 37 times with 2 left over, and I bring down that 0. 4 goes into 25 times. These two answers are equivalent, 8 3/4 or 8.75. That's the number that's missing right here. And this would have been a difficult problem to solve using the other methods. That's why it was really nice to be able to use cross product. We can also use cross product to decide if something is a proportion. Looking at this, sometimes a student might think that this is a proportion, that these are equal, because 4 is only one number away from 5, and 5 is only one number away from 6. In order to check, I'm going to use cross product. So starting here where I start, 4 times 6 is 24, and that number goes over here. And then 5 times 5 is 25. And then I ask myself, is 24 equal to 25? The answer is no, so I put a slash through my equal sign, and the answer to this would be no, this is not a proportion. I can do that same thing on this next problem, testing. Starting in this corner, 3 times 22 is 66. And checking this other side, 6 times 11 is 66. So the answer here is yes, this is a proportion. So the best thing about proportions is that there are 4 spaces when we set up a proportion. Since we've got the 2 fractions, we've got 4 spaces where we have the ability to fill in numbers. When I make my proportion with a ratio equal to a ratio, I've got 1, 2, 3, 4 spots where numbers can be filled in. So this is why I said at the beginning of this lesson that using proportions is so useful in problem solving, because many problems that we read have a ratio and a missing component of a ratio. So here's an example using my festively plump cat Kiki. The vet told me that I needed to give her these vitamin drops, and she was supposed to get 1 teaspoon of the vitamins for every 5 pounds of her weight. Now, Kiki admittedly probably needs to go on a diet. She weighs about 18 pounds, so I need to know how much medicine she should get. So the first thing that I'm going to do is I'm going to go through and highlight the numbers that I have. I have 1 teaspoon 5 pounds, and 18 pounds. So hopefully what you've noticed in these numbers that I've highlighted is that I've got 3 numbers and 4 empty spaces, which will leave me with 1 left over. And these 3 numbers have 2 different units. I'm talking about teaspoons of medicine and pounds of how much my cat weighs. So I'm going to put all of the information that I have that is measured in teaspoons on my top line, and I'm going to put all of my measurements that involve pounds on the bottom line. Now, if you flipped these and had pounds on the top and teaspoons on the bottom, that would be perfectly fine. You would come up with the correct answer. So now I go back and I need to fill in these 3 numbers that I have. My cat should get 1 teaspoon, so I'll fill that in on the top, 1 teaspoon for every 5 pounds that she weighs. And she weighs 18 pounds. Well, since this is a number that's measured in pounds, I'm going to put that on the bottom. And the missing number then will be x. Now I have a proportion that I can solve. I'm going to go ahead and solve it using cross product. 1 times 18 is 18, and that's going to equal 5 times x, which is 5x. To get the x by itself, I'm going to divide both sides by 5, because 5 divided by 5 is 1. So that's going to leave me with x equals 5 goes into 18, 3 times. 3 times 5 is 15, so I'd have 3 left over. 3 and 3/5, which is 3.6. 3/5 is one of those fractions you guys have memorized. And let's go ahead and move Kiki, see if our answer is correct. Yep, 3.6 teaspoons, how much she should get for her weight. Here's another proportion problem. It says Haley is going to make punch for a party recipe. She has made 12 servings, and it called for 2.5 cups of grape juice. If Haley wanted to make enough for 8 servings, then how much grape juice would she need? Well, I've got 3 numbers here and 4 spots in my proportion. Looks like the 2 units I'm talking about here are servings and cups. So I'm just going to go ahead and put servings on the top and cups on the bottom. So it looks like in this recipe, 12 servings of punch needed 2.5 cups of grape juice. Haley wanted to make enough for 8 servings. Where would the number 8 go? It would go on the top because that's where all my information about servings goes. And this empty space is left over for my x. I'd like you to go ahead and finish this problem on your own, solve using cross product. And here's another one. There are 3 brown mice to every 2 gray mice on Old MacDonald's farm. I've got 3 brown mice, 2 gray mice. If Old MacDonald's cat caught 18 brown mice, then how many mice did it not catch, the gray ones that were missing? And it's the same thing. I've got 4 spaces for these 3 numbers, and we're talking about brown mice and gray mice. So this first line, it says there are 3 brown mice for every 2 gray mice. If Old MacDonald's cat caught 18 brown mice, 18 is going to go up here because they are brown, and I've put all my brown information on the top. That leaves this missing number down here to be my variable x. I'd like you to finish this proportion. You might notice a relationship between the numerators, so you might not have to solve with a proportion. And here's 2 final questions that I would like you to solve. Remember, you can pause this video here to copy these down. And here's a motorcycle race using equivalent fractions, tinyurl.com/Carnes ratios.